battery pack can show an acceptable resting voltage and still fail to deliver usable capacity under load. Surface charge, recent charging, temperature, load history, and battery management system behavior can all influence the reading. That makes open circuit voltage useful for triage, but insufficient for release, warranty, repair, or replacement decisions. Capacity validation begins by defining the decision the test must support. Before selecting equipment or placing a pack on the bench, identify the battery chemistry, pack version, BMS state, manufacturer limits, and approved operating conditions. Then establish the charge mode, discharge current, rest condition, sampling interval, cutoff logic, connection method, and acceptance rule. The instrument must fit that workflow, not define it. Safety controls also begin before testing. Confirm connection integrity, authorized current limits, temperature observations, and the isolation status of any pack with an uncertain initial condition. A charge-discharge tester supports an approved process. It does not replace site procedures, escalation rules, or qualified battery handling. Once the profile is approved, run the charge, rest, and discharge sequence without changing parameters simply because the curve becomes inconvenient. A capacity value is meaningful only within its defined test conditions. Results obtained under different loads, rest periods, or observed temperatures may not be comparable, even when the displayed voltage appears similar. The stop event is especially important. A capacity figure without a cutoff reason can hide a BMS interruption, temperature event, poor connection, time limit, operator-selected threshold, or another exception. The record should identify the applicable voltage, current, time, capacity, temperature, and protection event cutoffs, along with the specific condition that ended the run. Curve review provides the context needed to interpret the result. Examine voltage over time, current over time, calculated capacity, temperature observations, and any interruption or abnormal behavior. The purpose is not merely to obtain a precise-looking number. It is to determine whether that number was produced by a controlled and valid procedure. A defensible record includes pack identity, equipment and configuration, operator, date, approved profile, rest condition, curve or summary data, capacity result, cutoff reason, observed exceptions, and final disposition. Export capability can simplify retention, but a spreadsheet alone does not make the result auditable. Ownership, consistent naming, protected retention, traceable equipment, and review responsibility remain essential. Repeatability does not mean every battery must return an identical value. It means the inputs are controlled, tolerances are known, and the procedure defines what happens when a repeat test materially changes the outcome. Retesting may be appropriate when a run is interrupted, conflicts with observed symptoms, falls near an acceptance threshold, or was completed under conditions that differ from the approved profile. Equipment selection should therefore focus on workflow evidence. The DSF-40 case includes configurable charge-discharge settings, data sampling, curve drawing, and Excel report output. Those functions become relevant only after buyers confirm the applicable battery profile, cutoff controls, connection arrangement, reporting needs, and exception path through current documentation, a sample report, and a representative demonstration. After review, the pack should follow a documented disposition: release, repair and retest, engineering review, safe hold, or qualified end-of-life handling. An unexplained interruption or conflicting result should trigger clarification, not a favorable assumption. Controlled testing can support better capacity decisions and reduce unnecessary repeat effort or replacement. It does not, by itself, prove remaining calendar life, transport suitability, recycling compliance, second life eligibility, or future performance. The defensible conclusion is narrower and more useful. Under the approved conditions, the pack produced a traceable capacity result with a clear stop reason, review path, and acceptance decision.